This is Henry Yost.
Yes, Henry.
Yeah, the video you provided in the email from last week's session, if for the team, if they want to navigate to the 1 hour, 7 minute, 50-second time stamp there, you have a you make a statement there that makes me laugh every time I hear it.
Uh-oh.
You have to go navigate there and just play it. I heard you say it last week and it made me laugh, and a good thing I was on mute.
So 1 hour, 7 minutes, huh?
1 hour, 7 minutes and 50 seconds. We're talking about that's the spaceship and gluing the project to and cutting the project out without tabs.
Oh, okay.
So,
well, I'll have to check that out. At least I knew I was on open mic, so I guess I'm responsible. So let me back up here a second. Leon, was that you who asked about Photo VCarve?
Yes, it was.
So I'm just looking at VCarve 11, and you have VCarve 11?
Yes.
Photo VCarve is included with that.
Really?
I'll swing the program up here. So Photo VCarve is right there in the upper right. Let me bring it a bitmap. So here's the photo. So like I said, it's been a while since I've used Photo VCarve. But let me give this a try. It works off the contrast of a photo. So photos, much like, actually in this case, unlike bitmap tracing, photos that have a lot of gradation in them, although you do want some really nice dark areas and some really nice light areas, they usually Photo VCarve the best, as opposed to something that's all really dark or all really light. So good contrast is important, but gradation or the variation within that. So select this here. This is Photo VCarve Toolpath. And so let's just see, maximum carving depth. I'm going to accept the defaults here, 60-degree bit. A raster will go back and forth at an angle. A hatch goes back and forth both directions. Line spacing. Yeah, let's just accept the default and see what this looks like. So you can't see much here when you look at the 3D view, but if you tip it a little bit, you can start to see the image. Okay. And then if I do a preview of it, that's the idea, is that where it's dark, the V-bit actually carves deeper, and then where it's shallow, it doesn't carve as deep. And within this toolpath setup, I could even go up here and do a little toolpath fill on that, add a little color to it, even highlight it a little bit more. So some of the variables within Photo VCarve that you deal with are the depth of cut, the step over between cuts, and then of course the angle.
Yeah, and that's very similar to the app when I downloaded it. The only difference I saw was they said one way to get rid of some of the background is just to blot it out, take the picture onto a photo editor or something, blot it out and then bring the picture back in so you just have the parts, and that also helps develop the contrast a little bit.
It's true. And they have within at least VCarve Pro, I'm not sure about desktop, but they do have a small picture editor in here as well. See if that'll open up. Oh, I have to close this first. Let's see here. Oh, it did open up. Let me close that anyway. And here you can add some contrast to change the picture, a little highlight that way. And you can play around with those settings as well.
Yep.
And then the one other thing too, much like bitmap tracing, is if you add a vector around it, I'll just do this really crude and quick. you could actually select the area that you want a VCarve or a photo VCarve. So, and again, I could actually use the bitmap to create a vector around this as well. I wanted to. I got to make sure that's closed. So I'm going to move in and use my trim tool to trim those off. And there's this crop bitmap right here. Let's select the picture. There we go. See if that'll do it. Reset. Well, we got kind of close. But anyway, you can play around with that and try some of those options. But that's the basics of how the vector photo VCarve works.
Great. Thank you so much.
Yep.
I appreciate that.
Sure. Any other questions from anybody before we get started tonight?
Hey, Randy, are you going to be covering anything on inlays?
VCarve inlay, that type of inlay? Are you familiar with that?
Right, where you can match up the two pieces because one's the inverse of the other or
Yeah.
the negative of the other.
Yeah.
Put them together and slice them.
Actually, let me make a note of that. I probably won't cover it tonight, but I do have an article that I can send you on that covers the technique. I'll send that out this week. And if you have any questions about it, drop me an email, or else we can also talk about it next week.
Also, somebody wanted to know a tool to do real detailed text last week. I brought it up. I forget who was asking. They were doing a coin that was like 1.5 inches.
Yeah.
But-
yes, Jeff.
So there's a Freud CNC router bit sign making set. And in that set, there's two that I've used to kind of do that. And that's a 32nd inch tapered ball tip and a 16th inch tapered ball tip. They have 6.2 degrees and 5.4 degrees to give you an idea of how detailed it can go. But that's where you can find them.
Great. That was me, Jeffrey. Thank you.
Oh, you're very welcome.
Yeah, for doing really detailed 3D carving, those are very good bits.
Jeffrey, this is Margie. Can you put that in the chat, please? So I make sure I'm writing it down correctly.
So welcome everybody to class 3. Tonight's main topic is Toolpath tools and settings. But leading into that, we're going to wrap up a couple of topics from last week that are actually excellent entry points into the Toolpath discussion. In particular, we're going to look at a couple things on the circle, text in a circle, and then solving some vector problems, which is part of tonight's topic as well. Because if you don't have good, clean vectors, then you have trouble doing toolpaths. Okay, we're going to take a look at the text in a circle, which was the challenge project, and was mentioned at the pre-class Q&A tonight as well. So I've already created the basic circles using the offsets or the diameter for those to mimic what my drawing looks like, the picture looks like, and I've also created some of the text. So I've got that basically set up. And as I showed you last time, when you use text in a circle, opening up that tool, it asks you to select a single line of text and then the vector. So I'm going to select this one first. Actually, let me select this one down here at the bottom. And we want that to lay either on the top of this line or it could go on the other line. But just for simplicity, I'm going to click that one. And you know what? It bounces right into place. Everything looks pretty good. All we need to deal with here is the offset. So I'm going to type in a 1/4 inch offset in that. And the only trouble I have right now as I look at it, I can tell that my lettering is a little bit taller than that. So I can close out of this. I can actively select the text and go into my text editing tool and just change the size of it. So let's change that to say 3/4 inch. That looks a lot better as far as the scale of it. I can then just hop right back into my text on a curve tool. And what I can see here is I want a little bit more offset. So I'm going to take that up to say, let's try 0.4. And that looks pretty good. Now, the other thing I could tell right away is that my spacing is a problem. So I could use the spacing tool and click between each of those letters to increase it. Or in this window itself, I also have the text spacing tool right here. So I'm going to click on that to kind of activate it. And then I can use the scroller bar. I mean, I can manually slide it up and down like that, or I can use the wheel on my mouse. And as you can see, it just dynamically change it up and increase it. So I'm going to, that looks pretty good right there for now. Let's see, get that T just a little bit further away. And I'm going to accept that. And now again, if I wanted to go back and tweak it again, I could go back into my regular text spacing tool. And if I wanted these to be a little closer, I could just click between those. I might want these a little wider, so I hold the shift key down, make those a little wider, a little closer on those. And again, like we looked at last time, you can just go around and tweak it to where it fits the size of your project. So with that done, I'm going to hit the escape key to get out of the text editing tool. There we go. Next up, I'm going to select this side up, and I'm going to select the same vector. And go back inside the text editing tool, or rather text on a curve, and it does the same thing. It bounces it to the bottom, the same as before. Okay, so let's see if we can fix that. We want it at the top. We want it to look like this side up over here. So let's try on the other side. Well, that puts it upside down. What about if I put below the curve? And this is where I was showing you earlier. You'll start to play around with this, and it'll, okay, so I'm kind of close. If I go to the right side, I'm over there. And what you're going to find is just going to start bouncing all over. You're going to have a hard time going where you want to go with it. So a couple things to pay attention to when you're in a situation, somewhat unique when you're in a full circle. But that little green dot right here is the alignment node or alignment spot for the text. And you see right now I've got align right, okay? And let me go below the curve here. What if let me back up, close out of that a second. I'm going to start over fresh. I could go in here and I can remove the text from the curve and just make it straight again. And I'm going to take and move this one just out of there for now. And we're just going to work with this one again. So I'm going to go back in there inside text on a curve. So you notice how I have the alignment set up here as aligned to the right. If you think of this circle as a single line with that green dot being the end or the beginning of the line, then it makes sense that right now our text is aligning itself to the right end of the text, which is the P letter. If I go left, it's just like aligning your text to the left side of your line of text. So it's aligning the left of it. And if I go middle, it's aligning it to the bottom here, because this line, this circle, starts at the top, wraps around, and ends over here. And here the green dot represents the middle of the text. So that green dot really represents the middle of the text, the left end or the right end, and it's aligning that green dot to this circle. So you're going to find as we go on tonight that this topic of this start point or this alignment point comes into play in a lot of things. So let me close out of here for a minute. I'm going to go in to the circle, select that, and I'm going to go into node edit, which we've talked a bit about. We'll be talking in more detail tonight as well about node editing. And notice we also have a green node or a green spot, definitely a green node in this, and that is the start point. And so the reason, if you were to unfold this line, that would be the beginning or the end of the line right there. And that's why the text circles around. So it makes sense that aligning the text to the middle of that line, it's ending up at the bottom. So basically what you need to know is that when you're aligning text to a curve in a circle, when you align it to the middle, it'll flip to the opposite side of the start point. So if we want to move this to the top of this screen up here, what I need to do is go down to the bottom, put my cursor over it till it turns into the crosshairs, and right click. And now I get some options, and one of them is make start point. So I can actually move the start point for that circle to the bottom, and then I will double right click to exit out of the note edit mode once, twice. Now I will take my text, select that line, go back into text on a curve, and now you notice how it bounces to the top. Now it's upside down. So let's go to the other side of the line. That looks better. And let's go below the curve. So now you can see we're matching the way we want it on this one over here. So now once again, our spacing is tight. So let's go ahead and we want some offset. Let's use the same offset we did before, which was 0.4. Of course, we also need to change the size of our text. So one of the great things about VCarve that's improved over the years, it used to be that when you exited out of these tools, you would lose your changes and you weren't able to go back and edit things. Or if I went into the text tool, it would automatically take it off the curve or deal away with my spacing. But the last few versions, they've done a good job of being able to maintain your previous setup. So I could change the height of this on the fly. And then I can go back into my text on a curve and I can place my text spacing and make that work as well. Now, I pulled this one out of here and it might be kind of tough to get it perfectly centered. So what I'm going to do is simply go back in, say, remove text from a curve so it's straight again. Now I need to select that curve, but remember, remove the start point. So I'm going to go back into Note Edit and go back to the top and move the start point back to the top. Double right click to exit the Note Edit mode. Select the text that's down below. Notice how the spacing on here looks a little odd, and that's because it actually did retain that spacing. Select that vector circle and open up and there we are. And all the settings were pretty much the same as before. Let's see, we need to do another offset. So I'm going to type the offset in there, 0.4. And that looks pretty good. So it's a bit of a manual override that you need to do on what's called the start point to do the inside and outside like that, or the upside and downside. Now, to do the round and round along the inside, which looks like it's continuous, it's a similar kind of approach. I'm going to select that. I'm going to select that vector. Go back inside text on a curve. It says it's too long to fit on the curve. So it's going to cram it in like that. Well, that's okay because I can go in here, my text spacing now, and just space that out a little bit to where it fits the way I want it. And it's also scaling the text up here so I can actually reduce the text size a little bit if I wanted to. So you got a lot of stuff here that you can do on the fly. Let's see here. Let's try. Okay, it's too big. All right, so then we'll just do the, oops. Just do the text spacing. Till that fits. That looks pretty close. I've got a little tight spot here. I can deal with that later. I want a little bit of an offset though, so let's add about the same amount of offset we used before. Close that out. Now I need to add a little space between those two. So let me see if I can do that with my space tool. I may or may not be able to. Let's see. Yeah, looks like okay, so this is one of those spots where you might get hung up and it's actually not letting me add because that's actually the end of my line of text. So the other option I have here is I'm going to go in and manually change the height of this. And it's not letting me do it. So let's try something else. Let's close out here. So what I'm showing here is that sometimes you need to work a couple different angles, and there's sometimes 2 or 3 ways to get the job done. But in this case, I'm going to go back inside my text. And because I have this unusual spacing, and that part of it did get frozen, I'm going to go in and change the font on this, which redoes the spacing, close out of that, just go back in, see if I select my original New York Times or Times New Roman, if that'll, yeah. So now I've got some decent text spacing. I'm going to change the height of that to 0.375 right in here, because it might be best to change the height here instead. Now I'm going to go and get the inner circle, do the text on a circle, and now I can go back in and I can rotate that around until I get just the kind of spacing I want. And you might even be able to make the text a little taller. But you just, like I showed you there, at the end of the line, you won't be able to do much with the text spacing tool except for this manual one right here, which stretches it all out. So that's for setting up those items. Now we do need some offset on that. So I'm going to go back in and add my offset. And that helped with the text spacing as well.
Randy?
Yes.
Is there a way to force a space at the end of a line?
You know, it's possible. Let me see here. If I go into this, I am not sure. That might do it. Let's see what happens. No, it doesn't look like it's still running into itself. See that? What I've noticed, if you look at the top of the circle, the 2 letters are running together. What I've noticed in some computer programs is that if you have the space at the end of a line, like this even happens on some naming configurations, it ignores it. So in this case, it doesn't look like you can force a space right there. But you might want to test that. Maybe there is a way to do it.
You may also want to try it at the beginning of the.
That's possible as well.
R.
Yeah, sure. Let's go ahead and see what we've got. So see, it did away with that spacing. Now, what about at the beginning? Let's try the beginning. And now if we go back into the spacing here, still is running into itself. So we got really close here with it like that. But those are both that's a good thought. You know what? Look at that. It actually removed it again. So this is one of those text programs where it appears to be ignoring space at the beginning or the end of a line of text, which generally works to your favor. In this case, obviously, it doesn't. Any questions about that text on a curve? If you figured that out over the week, give yourself a pat on the back. And if you didn't, now you know the little secret to doing that. The last thing here, of course, would be just adding a simple star to the middle. And again, this number of points. So here's another one too. You can see the little crosshairs that are popping up. That's because, well, actually, I don't have my snap lined, but it does help with the snap as well. And I just could stretch that out and you've got your dimensions over here. or I could just draw one manually and stretch it as large or small with as many spots as you wanted on it. Now, we talked a little bit about tooling before class tonight, talking about the ball nose bits for 3D carving and V bits for V carving. It is important to differentiate that, or when you use a text or you want to do V carving of this type, it is important to use a V bit for that process, because text in particular, although you can carve it with other types of bits, you get the best results if you use an actual V bit as opposed to a ball nose bit or other types of bits. Some people are tempted to use like a 16th inch or 1/8 inch, or well, rather a 32nd inch end mill, and you can do that, but you will get inside round corners. So the V bit is by far the best choice. And in this case, I've got a 60-degree 1/2 inch diameter V bit selected. And it will give me some nice detail. Now, one of the tricks when you set up a bit, if all of your settings inside this V bit, and we're going to be talking about these settings later tonight, if all of these settings are set up the way you like them, after you create one tool path, there's two things you could remember here. One is if I want to edit that, I don't need to create a new toolpath. I can just double click on the toolpath icon right here, that tool bit, or I can use the pencil and I can go right back into that toolpath and make my changes. So if I wanted to rename it in here, now I have this very same toolpath, but I just gave it a different name. You could also access some of these options from right here with a right click. And here you can see you can also rename it. Or the one that I was going to mention is by duplicating it. When I duplicate it, it is an identical toolpath. It represents the same vectors. You see the red vectors? It represents everything is identical about it. But the most important thing about the duplicate is that when I open this up, again, it's the same vectors, but I'm going to use this one for the star. And that way I don't have to go back in and pick my tool bit. I don't have to set up the feeds and speeds or any of that information again, or any of the other settings that are in here. I just have to go in and verify that I want a different vector. And in this case, I'm going to go ahead and add a flat depth of 0.25. And I'm also, because I've got a fairly large area in the middle here that I can clear out, I'm going to actually add what's called a clearance tool, which typically is a end mill bit. So I'm going to select that, find a 1/4 inch end mill right here. And I'm just going to accept these settings for now. So I actually have two bits set up at the same time. I've got a V bit up here for doing the V carving part or the detail, and I've got an end mill for doing the clearing in the middle part of it. Go down here and click, let's add a little ramp. Always a good idea to add some ramp to a straight bit. Usually 4 times the diameter usually works pretty well. Click calculate. And now you can see at the bottom right here, I have my double, actually it's called text. So let's go back in here, open that up again and rename that star instead.
What's the ramp again?
Question?
Yeah, what's the ramp again?
Oh, so a ramp right here is, think of it like a boat ramp easing into the water or a wheelchair ramp. It eases the bit into the material. So if in this case, my end mill right here, and it's referring to the end mill is the one that I'm ramping. If I look at the details of my end mill, it shows me, let's say I'm going to cut 0.1 deep for each pass. Okay. So that's my setting. I'm going to cut a pass depth of 1/10 of an inch. So what the ramp does, is it will reach that 1/10 of an inch depth of cut over a 1-inch length. You with me on that?
Yep.
So it's a boat ramp that's an inch long and it's going down to the water 1/10 of an inch. So that's what it does. It eases it in. So we're going to calculate that. Yeah, question?
So for a 1/10 of an inch, that whole inch spread out, it goes from 0 to a 1/10 of an inch over an inch.
Correct.
Okay.
Exactly.
All right.
Yep. And a rule of thumb, like I was mentioning, is that somewhere between around for these small machines with these shallow depths like that, 4 times the diameter of the bit is a kind of a rule of thumb that works well. Some people use 8 times the length. It depends on, again, like if you're cutting, big machines would cut through a sheet of 3/4 inch plywood in one pass. They may use 6 to 8 inches of ramp as they go down. And there's other strategies for doing that. But it just puts a lot less stress on the bit and on your machine. It also gives a cleaner entry point. Otherwise, the bit ends up acting a little like a drill, and it will often wobble a little bit as it goes into the material and create a dwell mark. So the ramp helps in a lot of different ways. So as I mentioned, we now have 2 bits set up here. We've got a clearance bit and the V bit. You can actually look at the icons before them, and one's a straight bit, one's a V bit. If I turn off the visibility, the check mark by the V bit, this is where the straight bit's going to cut. You can see the path of it. So let's preview that. So the end mill, so that just roughs it out. And then the V bit just goes in and does the area that the straight bit was not able to reach. And as a result, you end up with a much cleaner bottom, because if we were to, let's go back and I'll redo that bit, and I'll take the clearance bit off, unchecking this on the right side, recalculate it, reset it. Now everything is being cut with the V bit. It's going to take longer, but you can also see you visually get a little bit rougher surface at the bottom because it's being trimmed out with the tip of the bit. So when possible, it's a good idea to add a clearance bit because that helps to give you a cleaner surface. Now, there are situations where the clearance bit won't fit all the areas. You'll still end up with some little rough areas. They're usually not too bad, but sometimes you have to go in and clean them up with a little carving tool or sharp chisel or something like that and scrape them smooth if it's important. But let's look at, okay, so I also have set up the other 2 tool paths for this, for the VCarve circles. In that case, I've just simply selected those and it'll cut between those. So let's preview those. And then I've also got the text. We'll do that again. And the cutout, as I showed you earlier, the cutout, I am going to, I'm using this line for the cutout, and it's cutting to the inside of it. And these little marks you see here are actually tab locations. I can also visually look at this by selecting this option here to see a solid view of it. And that light blue shows me exactly where the bit's going to cut. And we did this on the UFO also, is that it's going to cut the outer half of that V carving away, leaving us a nice bevel on the outside of our sign. Any questions about that? Okay, then. So you've got this information. So if you didn't get to the challenge project or it kind of hung you up, give it a try. It's a nice way to add some real creative text. Now, the other thing about, we did text in a circle tonight, but if you had an S curve, your text will actually follow an S curve or a wave curve. So you can get that text to follow pretty much any shape you want.
Hey, Randy,
Yes.
how I got a little bit tired of playing around. I just ended up taking and rotating the text using the dot.
Oh, sure.
I didn't know about the little trick that you showed us, so I just
Yeah.
got a little bit frustrated and said, I can rotate that thing.
You can. Yeah, I mean, you absolutely can. You could go in and create a letter, either a word or something like that, and you could go in, and if you wanted to, you could keep that all in line. You could rotate it either individually or separately. You could rotate them and add them. Obviously, text in a curve is a little quicker, but the text will respond to rotation just like any other shape. So not a bad idea.
I had it on a curve, and it was always on the bottom, and I just got irritated with it, and I said, I'll fix this thing.
Well, you're in good company with the irritation, because that's one of the reasons I show this, because I get asked that question so many times, because it seems like this just should be really easy, but it's just not obvious until you discover that start point. Okay, so we're going to jump into some node editing. So some things in VCarve are just strictly technical information. You just kind of grab it like drawing a square, you put the dimensions in and you set the dimensions, you do the alignment to the middle or to the left, to the top. It's just very basic kind of operations to move things around. Node editing is a little bit more of an art, and it's a little bit more mysterious because it's not something that any of us as typical woodworkers have ever done in our life before. You know, we can make things fit and saw things to very precise sizes, but we start moving stuff around in the digital world with drawing, especially node edit, it gets a little bit unusual. So first of all, you do have a copy of this. And if you looked at it, I pointed out that there are several kinds of nodes and several kinds of commands. So there's an arc node, which is this open green one. You've got a light gray one, some red ones. You've got single handles that are like antennas. You've got straight teeter-totter ones. You've got single arms. Again, you've got a green node and some other symbols. So what I want to do is I have this actual shape over here. We're going to take a look and walk our way around this shape, looking at the node edit. Now, the quickest way to get into node edit, other than right-clicking and hitting node edit, you see the N right there. That's the shortcut key, as are all these up along the top here. So I can simply hit the N key on my keyboard, and I can enter the node edit. And one thing to notice about node edit, let's go back over here a minute. You see the shape of my cursor. It's that arrowhead without a arrow shaft on it. That's because I'm in node edit. If I hit the N key again, it goes back to the standard cursor. So you can toggle back and forth between node edit and standard very quickly with the N key. It also gives you a hint as to whether you're in node edit or not. Of course, I'm in node edit right now, but there's no node showing, and that's because I haven't selected my line yet. So to do that, just like any line, I click on it, and then the nodes all become apparent. Now, as I mentioned, this type of node, which is this open green node, is a arc node. And you can see this nice even arc going along here. Now, arcs are geometric shapes that I can grab that, left click it, turns red, and I'm holding the left mouse button down, and I can stretch it up or I can stretch it down, and it maintains an arc shape. Now notice that I can only go up so far with it because it'll only hit a semicircle. That's as far as I can stretch it, is a semicircular shape, because it's an arc. It won't continue to create a circle or a bubble or anything like that. So it does have some limits. The other thing that's you notice is that when I get close to the line, my cursor develops that line symbol next to it. Or if I go next to a node, it turns into a crosshairs. And any of the nodes will turn into a crosshair. Or if you go next to the line, it's a line. This line symbol, if I right click, it brings up a local menu that allows me to do certain things. And only those functions that I can actually perform are highlighted. So I can't convert this to an arc because it's already an arc. However, I can convert it to a line, which makes it go straight, or I can convert a line back to an arc, or I can take that arc and make it a Bezier. Now, a Bezier is somewhat unique because it has these arms. So these are, if you think of these kind of like drawing a French curve, if you're familiar with that term, this is an irregular shape, and this is where the art comes into it. This is takes a little bit of practice to make these things work. But again, I can go back and take it back to an arc just the way it was. So you can edit both line and nodes in a lot of different ways. So if we travel down along here, I have a black node, and a black node is pretty much just like a stake in the ground. 2 line ends come, it's the end of the arc, it's the end of that. There's no real function you can do it, although I can grab it, left click on it, and I can stretch the 2 lines that are next to it, and they will drag like rubber bands to a new location. So I can do that. I can also, if you remember last time we talked about selection, and I'm going to demonstrate that again tonight as well, but if I select a little square around it, it highlights it red. I can now use the arrow keys on my keyboard to very precisely place it. And for those of you that really want to get into the details, if I right click and I go all the way to the bottom, I see something called properties. And I will be honest with you, I rarely use this because I don't do a lot of what I would call engineering layout with my designs. But if I click on this, it actually gives you the absolute or relative location of that node. So if I wanted to move it exactly a 1/4 inch positive in the X and a 1/4 inch positive in the Y, I could use the relative one. It'll move it relative to its existing location by 1/4 of an inch, click apply, and it moved it exactly that amount. So it's surprising how much fine tuning you can do. But like I said, I rarely use this properties function. I have occasionally, but I just want to point it out. So it is there if you want it. Okay, so as we travel on down along here, again, you may not see this in your display, but there's a little gray node right here. As I'm traveling down, you'll notice I get the crosshairs. That's because there's a little hidden node, and that's a midpoint node. It's semi-hidden, but if I click on it, it becomes visible, and I can stretch it, and it automatically inserts a corner node right there. And all of a sudden, I have 2 more mid nodes. So every time you stretch a straight line, it puts a new mid node in, and you can keep stretching those out. Now, once you've stretched those out, you can do some things to these. So if I want to make that a curve, I can smooth it, it's called, and it turns it into a Bezier curve. And now I've got some Bezier handles that I can play with. Or I could go in and let me go on the line here instead. And I could convert that. It's not letting me do an arc. I'm wondering why here. There we go. So now I've got an arc over there. Again, going back to the fact you can edit those. But if I want to undo anything, I can Control Z, Control Z, Control Z, and I can just take it back to where I was. So the midpoints are really handy. Now, if we move down to the corner here, we have another black one, but we have a single handle. And that's because we have a straight line going along here, and then we have a curve here. So when you have a straight line intersecting a Bezier curve, you'll have a single control handle. And I can pull that around and make whatever shape I want with that. Up here, when we left, I have this node, but I have a continuous line between it. Let's say if I was slightly off like that, and I wanted this to be straight between there, I can simply, I can try and get that aligned, but I'll never get it exact. So instead, what I'll do is I'll go into this node edit and hit delete point. And now it just makes it back to one continuous line. So deleting points is an easy way to clean up some shapes if you have too many nodes. If we move down along here, down here, it may be hard for you to see this in your screen, but this node is actually a dark blue. It's very hard to tell it from the black, but because I have independent control handles, each of these curves here, I can control independently and make any kind of shape I want with it. And this is a nice setup when you have a point that you want to go into some sort of curve on both sides. So this is a single and this is a double. In a similar fact, actually, I take that back. This is the black node right here with the split handles. This node, which is a blue node, has the handles that are actually joined like a teeter-totter. So I can make one longer than the other, but if I move one, the other one moves directly across from it. So again, it takes some practice to figure out, well, when do I need these? And what are the easiest ways to practice with this? And I've demonstrated a little bit of this, but I'm going to bring in another picture here. Let's see, what have I got here? Let's take this trout here, see if that'll work. Okay. So I'm in node edit right now, but looking at my cursor, so I'm going to double click right. Okay, so now I'm going to take that fish. And this is where, if this was actually a photograph, or maybe I'm not having luck tracing it with the automatic tool, the way I use node edit is I'll go into this shape and I'll just start clicking some lines at some high points and some low points. I can zoom in here. And just take some of the major points. Again, my approach to designing something like this is very much kind of a sketching approach, less of an engineering approach, because I find I'm pretty successful going back later. And as long as I have my snaps turned on at the top up here, when I reach the end, you see how it wants to be like a magnet? When I click on that, it actually has joined those two together now. And that is actually my start point. So that's one continuous line going all the way around. Now, this is a practical application of using node edit. And I'm going to work on the mouth here because it's probably the most complex up here. So I'm going to start with the chin. I just kind of drag that line down. Oh, one other thing, when you're doing node editing, turn off the snaps because they tend to force things where you don't want them. Okay, so I'm just going to start aligning a few things. I want to pull this guy down here to the chin. I want to go up to the top of the head up here, bring that up a little bit, bring this down here a little bit. And now I'm going to start adding some Bezier curves. I'm going to start in here, right click, smooth that point, shrink those down a little bit like that. Then I can grab this guy and just shrink it down right there. Bring that one up. Let's bring that one down to the bottom right here. Stretch that up. And this might be one. Let's see if this, yeah, this actually is working out fine. Let's take this guy, stretch this out. And it's surprising, fewer nodes is almost better than too many nodes because it's easier to control a couple rather than a whole bunch. So in this case, I'll do a little trick. I'm going to pull this out. I'm going to smooth it. And then I'm actually going to delete this point. And now I've got that coming around the bottom. I need to make this one smooth. And now I can match that to the bottom. Now this one is split and I really don't want that split. So I can go back in and basically rejoin it by clicking smooth again. And it'll now make it one continuous. And I've got one long handle and one short handle here. And if I need to move this up or down, move that out. And I also want to think I'm going to take this, see what happens if I smooth, oops, back again, Control Z, let's smooth that again. And this is where it gets tricky because I've got this inside the mouth I'm trying to maintain. I've also got this lip and I've got this guy going. I've got that. So with this done, let's go here, let's right click, let's make that into a Bezier. I can bring this out. Matches that. I can use that same trick and make that to a Bezier. Now I've got some handles here I can bring up. And so it's a little bit of practice. You can start to duplicate and trace shapes. And it doesn't take too long to get a shape traced just the way you want it. In this case, I'll right click again, and now I've got my vector going around that face. And I would just continue doing that around my whole object. So that's kind of a practical application for dealing with the different types of nodes. That pretty much covers all the different nodes. Again, this is the start point. And one other thing I could do any place along here is I can go in, let's see here. I can go in on that start point and I can do what's called cut vector. Now, when I cut that, I actually separate it. And I can do that any place along here I want. So I can make segments if I want to take a chunk out. I can get rid of all of those. And you just can continue on editing on that. I mentioned about the red nodes. That's a selected node like that. If you select two of them at the same time, you can actually move them at the same time using the cursor buttons. Or if you select them with your mouse, you can also drag them around in tandem, or as many as you want. So there's sometimes I'll select a whole bunch of nodes and stretch a whole shape out like that. So this is going to be more than many of you need when you're starting out, but when you get into tweaking images and fine-tuning some shapes, node editing is amazingly powerful for some of that. Any questions about the node editing?
Randy,
Yes.
how do you join those two that you've now separated?
Good question. So what I'll do is a couple options. If I want it over in the left side, there are some join tools.
Okay.
And this first one is what I call a close join. And on this one, you have to have things very close, basically like when I cut it. But the other three offer you some simple closure, like this one is just a straight line. So you'll notice that now I just drew a straight line straight across that opening. If I undo that again, select it, and the next one I'll join it with some sort of curve. There's kind of a curve. And then the other one, the last one, is pretty radical because it's going to bring the 2 points together. And it basically took those two ends and moved that arc down till they joined. So those are a couple of the quickest ways to do that. One of the common problems we're going to look at next is that sometimes you'll have a shape, which is a continuous shape, but you'll actually have a break in it. And it's hard to see. Like if I just go in here and cut, this is not a solid vector. If I were trying to VCarve that, it would tell me it was an open vector. And that's because those 2 points, no matter how close I go, I can't tell the break, but there is a break. And so next up, I want to look at is what I call cleaning up vectors. And this probably relates to, I would say, 80% of the emails I get probably are lined up in one of these problems that I'm going to show you tonight. So first up, and this is also the lead in, because when you're doing toolpathing, which we're going to get into after the break, one of the big problems with toolpaths, if you don't have good vectors, you're not going to get good toolpaths. So it really starts at the drawing side. So first off, I just want to give a quick demo of selecting vectors. Just as a review, I mentioned last week that if you do a single click with the mouse, left mouse, just on any one of those with the tip of the mouse or the tip of the arrow, you can select those vectors, or I could select the text by clicking on the text itself. But if my mouse or the cursor isn't really close to the tip of the, or the tip isn't close to the vector, even on these letters, I'm inside the middle of that C, but it's not selecting it. I got to get right down on that C to select it. So that can be kind of irritating sometimes. So what I typically will do, we'll just do a left drag coming from the left over. Whatever is inside that selection box will be selected. So if I just want the bottom two, it'll be the bottom two. And if I overlap the bottom two, but I want the top two, again, all I'm getting is what's inside the box. So sometimes that's a helpful way to select. The other option is maybe I just want to select a whole bunch of things and all I want to do is touch them. So whatever I touch with the vector going from the right side into the middle will be selected. So in this case, the bottom two are being touched by that selection boundary line, and they end up being selected. Same thing up here. If I select those two going from right to left, or if I just touch all four of them, they'll all four be selected. So that's some just simple ways of doing it. Of course, you also can just, you have either Control A in your keyboard will select everything on your screen, which is the easiest way to do that. Or you've also got a right click and you actually have this selection drop down, and the first item there is select all. And that'll also select all. Now, next up, what I want to look at in this whole selection thing, now that you understand how things are selected, is in this drop-down menu, you also have some things called select open vectors and duplicate vectors. And open vectors and duplicate vectors are two of the problems you'll have when setting up a cutting file, especially a VCarve file, because both of those will create some problems for the toolpath. So we're going to take a look at several scenarios that create problems. And I'm going to say that probably 90% of your vector problems and toolpath problems will be related to, if it's a vector problem, it'll be related to one of the things I'm going to show you. So first off, this is a logo. Let's say we want to VCarve this. And the results that I want, of course, I want this. That's my kind of my reverse V-carving. That's what I want. That's the way it should look. However, what's happening when I first start out is that's what I'm getting on the right side. And I can't count the number of times I've had people send me files and say, hey, all my letters aren't carving. And it's kind of fun because I'm pretty sure, 99% of the time I can go and find it. But it's interesting because almost every one of those has something a little quirky about it. And I'm going to demonstrate one tonight too that was sent to me this week. That was a brand new kind of little quirky problem that creates this kind of problem where it doesn't all carve. Now, you're going to notice this right off. If you select your vectors, the first thing you're going to notice, they all look good. But if you go in and let's take and VCarve these, let's do this VCarve here. And I'm going to calculate. And let's see. So it says the vectors may contain overlapping or intersections, which may be unexpected results. Would you like to use the validator? And typically I would say yes, but I'm going to continue anyway on this one. And now it's telling me I have 3 open vectors. So I actually get 2 windows here that are telling me there's problems. And so the first thing you need to do is solve your problem so you don't get these pop-ups. So I will show you, you can go to that point of using one of these pop-ups. The first one said use the validator. So let's try that again. Okay, so it says select vectors may contain overlapping or intersecting intersections. Go to the vector validator. Now I want to show you where the vector validator is before I actually use this. If we go back to the drawing tool, right, this check mark right here, this is the vector validator. So when I click on that, this is when I was in my toolpath, when you click use the vector validator, this is the tool you're going to get. And this vector validator is looking for 3 problems in particular. And I want to use the V-carving mode because I want to V-carve this because it's going to look at it slightly different. Now notice when I click search selected, it's giving me some errors right here. And if I were to go in and examine those, I would find some problems. And we're going to take a closer look at this vector validator at the end of the demo, but that's probably the first thing you're going to see. But first, I want to show you what these problems look like before we actually get into the solving all of them. So let me bring up a couple more items here. Let's leave that one on and get rid of our bitmap. And then, okay. So these are probably the eight very common situations that you're going to run into that will cause toolpath problems and design problems. The first one are duplicate vectors. So let me bring up information on that. So the way you know you have duplicate vectors, there's a couple things that are going to go on. Right now, I'm pointing to duplicate vectors. If I select this whole design, actually, let's do this. I'm just going to select those 2 areas. And then I'll select the B. Let me zoom in a bit. You should be able to see how the outside of the B looks like a nice, clean, pink dotted line, but the inside of the B here has a dark, a black, and a pink, what it looks like a dotted line. And the reason for that is because you actually have 2 lines on top of each other, or they're overlaying, they're identical lines. So the way to fix that, again, if I select all those, they don't show up because they're both selected. And this is where if I select just once, now just one of them slows up. I'm going to click again, and you'll actually see there, I've got 2 of them right there. And I got 2 right there. So you just want to take those, delete those, because when you get to your VCarve line, if you remember when I had the VCarve toolpath, it said you had a couple duplicate lines, and that's what it was looking at, were those duplicates. So you can tell it a couple of ways, like I said, but you have to click just on it for a single time, and you'll get that double pink and black line, and that'll show you where the duplicate line is. Now, I'm going to undo these and put it back in their place. I'm going to right-click, hit selection, and notice here where it says show duplicate lines. So if I click on that, it highlighted those duplicate lines right there. Oh, let's do it again. With those duplicate lines, and I can move those off to the side. And again, I can just get rid of those. So duplicate lines are one thing that are going to cause you trouble along the way. You just got to look for them and then get rid of them. Any questions about that? Okay, next up, open but not touching. This is much like I mentioned earlier, where you see at the right here, you really have the nodes are overlapping each other, and it's usually the start node. Well, it's almost always the start node. So that's the easy way to find it. If I were to go into this one, I can't see any open area, even if I look at the node edit. But if I try to VCarve, it would tell me that it's open. And if I stretch that out, of course, it is open. So the way to, another way to solve that, to make that a single line again, let me zoom in a little bit again here, is I go into my drawing. We talked about join tools earlier, right along here. We use those 3 general ones. This first one I mentioned, which is called the join tool, is for close joints. And particularly, it's good for this situation. If I open this one up, you'll notice how it's selected vectors. That's the inside of my A. It says I have 1 open vector, and that's because it's broken at that corner. The tolerance here I've set up right now is pretty tight. And that's looking at the gap. If there's a gap that's larger than that, it will ignore it. So I usually leave that pretty small. I think this is the default, so I usually don't mess with it. But then it says after joining, I'll have 1 close vector, which is what I want. So I'm going to click on join, and it deselects it. And if I select it again, notice now it says there's 1 close vector, and there's really nothing to close because I already have a close vector, and it's not giving me the join option. And if I go back into my node edit and I try and tug in that corner, I'm going to move everything. So little broken vectors like that are another common problem that you'll come across. And that's go into node edit, grab the start node and pull it, or use that join tool to try and find it and join it together, and that'll solve that problem. Any questions about open vectors and join tool? Next up, we have something called overlap. And an overlap is what you see here in this drawing, where the start node is stretched down over itself. And there's various reasons this can happen. But again, it's very hard to see. If you look real close, again, you may not be able to see it on your screen, but there's a slight darker line right along here. So if I go into node edit, again, this isn't really showing me that I have a problem. But again, I'm going to grab the start point and tug on it. And there we go. It shows me that something's going on. So usually the way I solve this, there's a couple of ways. I can stretch this down, but I'll usually go back in real close right here. I will cut the vector, and then I'll go into that span. Let's see what's happening here. Okay, let's go in right between those two. And I'm going to right click. Okay, so now what I've done is it's actually cut. Let's see here, what's going on here. Yeah, so I could take and just delete that section. And now I've got a little tiny short span that's very close. I could go into the drawing tool, and this again is where I can use this join tool with a straight line and join that back together. And now my vector is a continuous vector all the way around, and I no longer have that overlap. So it's a little bit of an investigative process sometimes. Number 4 here, which is a closed overlap. You can see what that looks like. This is a little trickier. It looks in a similar fashion to the last one, but notice there's no start point because it's actually a continuous line. So this can be a little trickier to find, but if I zoom in, I can see that darker line. And sometimes you just have to start playing around with your shapes. This is actually one of the trickiest ones to figure out where it is, because it may or may not be obvious to track it down. If I go into node, it's like, well, in this case, these corner nodes make sense. Those all look like they make sense. So really what I want to do, as I mentioned earlier, I've got some extra nodes in here. I'm going to go ahead and just delete those. Delete that point. Delete that point. And now I've eliminated those extra 2 nodes. But this will not give you an error because it's not an open vector, nor is it an overlapping vector per se, but it sometimes will cause problems. And sometimes you just have to get down to the nitty gritty like that and look for that kind of problem. So next up would be what's called the small gap. And a small gap is really just that. The parts are not touching, but what you see looks fine, right? That corner looks fine. But notice if I go in really close, there's a little tiny gap right there. And that'll prevent it from carving correctly. But as soon as I zoom out, it disappears. So the easiest way to fix that is, first of all, let's go inside our join tool again. And it says I have one open. And in this case, after I join it, it'll have one closed. So it's actually close enough for it to join it. So I'll go ahead and hit join. And same as the ones that we're touching, if I now zoom in, it's fixed. And if I look at node edit, it's a start point. If I pull on it, it's pulling both of them. So I have fixed that one as well.
Randy,
Yes.
on the one before,
Yes.
where it showed like it went a little zigzag
Yeah.
right there, wouldn't you would see that if you did a slow enough preview, wouldn't you, that your tool is moving weird there?
Well, actually, what this is showing is this is actually what you see. Yeah, so really what I was trying to illustrate here is that this node right here is actually overlaying on the line. So you actually don't
Right.
have a zigzag. But what's hiding is this setup is what I meant to be showing.
Well, would the toolpath still go back and forth
It would.
in that one spot?
Yeah.
Okay.
Yeah,
Okay.
yeah, I would go back and forth on that if it didn't cause some other, it might cause some other error along the way, but it would go back and forth on it. You may or may not notice it because it may actually be a perfect enough overlap where it may just carve it anyway.
Huh.
So a
Thank you.
loop looks like this when you zoom in on it, but what you see is nothing. And just like on this corner of the B again, watch as we zoom in, I still see nothing, but there's a loop right there. Again, not all of these are super common, but that's part of the problem, is because you'll come across these like, in 6 months or something. It's like, oh, it was that simple. But what'll be frustrating is you'll spend dozens of minutes or hours trying to figure out what's going on, trying the toolpath, this and that. And occasionally I've run into situations where I simply just redraw the letter or the shape or something, but I've gotten pretty good at finding out where the problems are. But I still occasionally, and VCarve is not 100% foolproof, there's still once or twice a year that I'll end up deleting a section of my drawing and redrawing because something in that line is just kind of corrupt. But before I delete anything, here's a couple of the tricks. I will save a copy of that file, open up the new one, and I'll do as little damage as I can to the design, trying to figure out where that problem is. Like if it's lettering, I may end up V-carving each letter separate, and I just try and boil it down. But sometimes it's just a whole lot easier just to redesign the letters or the shape or whatever along the way. It's also why I often will do toolpathing fairly regularly as I do my design work, because I might get a really complex design and have all kinds of little errors in it. And then I got to go back and find them all again. So it's kind of a work habit kind of thing to try and find these along the way. Anyway, in this case, if I look at the this is what I've got going on. Now to fix this one, the way I prefer to do it is go into my and use the trim tool. And this usually works. If I just trim those two, now it split them, but I'm not going to click anymore because I'll maybe, once I click close, it should heal okay. This is just a simulation issue within VCarve and computing. But there, you see how it snapped it right to the final thing. So it was kind of it was kind of stuck midway between solving the problem. So I just clipped off that little loop and that solved that problem. The next one up here is a line segment. So what you see if you select everything is this pink line, but it might be a little darker in part of it. And again, like the duplicate vectors, if you just click on one of them, the other one will stay black. And really what you've got going on here is you've got this remnant hanging out here or actually overlaying that other line. It could happen when you do trimming, which is pretty common. But again, if I select that whole B, it's not 100% obvious. It's like here, I can't tell that there's a little remnant along there. If I back out a little bit, I can kind of see a little darker line. But the easiest way is just click the B, and now I can see that black line is pretty obvious. So this is where I'm going to go from left to right, and just the object that's inside that selection rectangle, which will be that remnant, is selected. And there it is. So I can just get rid of that, and it's all gone. So the last one I want to show you here is, and I mentioned about the selection menu. We talked a little bit about here where you could use this to find your open vectors or your duplicate vectors. We talked about a little bit about the validator. In the validator, again, it will highlight problems that are occurring, and it won't fix them for you, but it'll show you where the problems are, so then you can go back in and focus on that area to do some of the corrections that I showed you just now. So that's the value of the validator. And it's not that you have to use, that you're going to need to use all of these techniques that I'm showing you, but somewhere you're going to come up with a toolpath that gives you an error, and you're like, how do I fix that? So I'm really showing you 3 or 4 different ways to get at it, whether it's the local menu, the validator, the join tool, or just clicking on the object itself. And these are all really valuable design skills, because I guarantee you one of these is going to come bite you sometime in the near future when you're starting to work with something that's more complex than a simple text editing design. So one other one here, let's turn these off. So I've got this bitmap of the fish, and I traced it, and then I used what's called the, as well as this oval. So here's my oval, and there's the vector on my fish. Now, when I traced it, you see all those nodes that I've got on there? And then when I did an offset, I got all these little tiny nodes also. But even on something as clean as an oval, when I do the offset tool, which I'll point that out again, this tool right over here for doing a nice even offset, you'll end up with all these tiny nodes. And VCarve has gotten pretty good about handling those little nodes and giving you a fairly smooth cut. But you will notice that if I were to V-carve around this fish, I'm going to get a pretty rough V-carving around it. Let me see if I have that queued up over here. Yeah. So you see all these extra static lines. That's because the VCarve bit is going up every one of those, or many of those extra nodes, because it thinks it's a little valley. And if we actually preview it, it's a little hard to see here, but you can see a little bit of texture along here. And that's because of all those extra nodes. So what I want to show you here is how do you deal with that? And for this, see if there's a local menu for this. Get out of the node edit. I'm going to go over to the other one over here. So what I'm going to do is this tool right here in the middle, it's called Curve Fit Vectors. It's right above the join tools, right in the middle. And let me select this outer line instead. So those are shadows of all the nodes that are in that outside shape. What this Curve Fit Vectors does is it simplifies the nodes. It reduces the number of nodes and gives you a smoother line. But I want this to be Bezier curves because these are some irregular shapes. And then the tolerance is how far am I willing to let that line vary from the original? And I'm going to set it at a 100th of an inch here and accept that. I want to keep some of the sharp corners that are inside. So I'm going to keep that. I'm going to replace the original vectors and click preview. And notice how it helped to reduce all of those vectors. I can do the same on the inside one. Replace those. And let's take that image and let's fade that way back. Okay. So notice I went from a lot of nodes to just very few nodes, and it saved my high points and low points in my corners. So now when I do a V-carving, it'll V-carve much smoother. And even with this oval, it's a good idea to do that. Let's see if we do arcs on this, if it'll maintain its shape. There, it did this all, these are all arc shapes now rather than Beziers, and it follows that oval very nicely. There are some times when all those extra nodes don't cause a problem, but it's generally a good practice to clean them up if you're seeing your V-carving coming out kind of rough, and that'll help smooth out the V-carve. So that's probably one of the more advanced setups for doing cleanup on this, but like I said, the place you're going to see it most and I guess what I changed, okay, so I had the wrong one selected, excuse me. Okay, here we go. The way you're going to see it most is when you do some tracing like this, as I showed you back here, that roughness that you can kind of see along here, and it's a little hard to see it in the simulation, but you will see it on some of your carving. Now, sometimes it doesn't matter. You know what, if you're doing just a rough sign or some sort of signage, it may even add a little character to it. But it's one way, again, to work around that. So that takes us to the end of the problem solving. I got a couple more things I can show you here, but I'm going to save that actually for next week because I want to take just a couple minute break here. And then we're going to get into the toolpath part of the discussion. Like I said, having clean vectors really helps when you set up your toolpaths. But before we break, any questions about what I've shown you in these 8 items?
Are the tiny line segments similar to the extra line segment?
Well, the tiny lines are actually, so if I had this image right here, let's get rid of that. The way the tiny lines come from, so I have this oval, that's a nice oval. These short segments end up occurring when I do an offset like that. Sometimes this will create a segmented line. Now let's see if it does it. Yeah, so like that. Rather than having just a few nodes like that, I end up with all of these. And the same thing happens when you do a tracing around a bitmap or an offset to a bitmap. It's basically you have more nodes than you actually need. And it will sometimes slow down your tool pathing. It will sometimes leave you a rougher edge. Does that help?
Yep, sure does. Thank you.
All right. Welcome back, everybody. Okay, the next section for tonight, as well as leading into next week, excuse me, is going to be on toolpaths. And I'm going to split this into two parts. One tonight, starting off now, is we're going to look at kind of the specs of it all. I'm going to look at some, this is going to be a presentation looking at different kinds of the basic, few of the essential tool paths, some of the setup, and we're going to take a pretty deep dive into looking at the chip load aspect, feeds and speeds. It's very technical, but I do it now, and then next week we're going to take and actually go into the software, and then I'll do a live demo of how to work within the database, how to create some custom tools, how to apply those, how to set up a tool path, and the different settings. I'm going to look at some of those tonight, but next week we'll actually look at a live application of it, and which then leads us in to the 3D toolpaths, which also leads us into the 3D modeling part for next session. This is probably going to be the most technical aspect of these 4 evenings together. I know some of the stuff we've done tonight, as well as last week, and the layers discussion that got pretty technical as well. But now we're departing away from the drawing side of the tool of VCarve, and we're going into the toolpath side, which is where you grab a router bit and you assign it to a line. So here's some 7 steps I've got here of successful machining. And, we just spent quite a bit of time on clean vectors. And tonight we're going to take a look at some of these other parts, as well as next week talk about it. But you want to definitely match your tool path and your bit. Again, you don't want to use a ball nose to do V carving, because V carving is made for a V bit. And generally, you're going to use an end mill for cutting out a profile. And there are some tool paths that really do work best when you pick the right kind of tool for it. Others you can mix and match depending on your design. And obviously, you want the settings correct for your machine, and that depends whether you have a small machine or a larger machine. Your material must be mounted securely. You need to calibrate your machine carefully so everything's lined up correctly. Test and practice is very important, and then track your results so you can go back and adjust your settings accordingly. So as I mentioned, we've jumping from the drawing side over to the toolpath side. I have VCarve showing right now, but some of you have desktop, and a couple of the primary differences between the two, or the one primary difference, that VCarve Pro will have these other tool template and merge tools that you won't have in desktop. They're more of a production item, so we won't be talking about those tonight. Also, you may see I have some of my software. I have the add-on laser app that I've been experimenting. It's not fully functional yet with some of the laser tools that are out there, such as the Shark laser tool, but apparently that's going to get resolved. I keep hearing it's going to get resolved, but they're saying now certainly in the next couple of months it should be fully resolved. And for any of you who have attended my webinars, I will hopefully be doing a webinar on that sometime this fall as well. But otherwise, the essential tool paths are right here in the middle. But another way to look at this setup is at the top, you've got something called material setup, which is very similar to the job setup that you did when you first opened up your file. You immediately recognize you've got some thickness settings here, some datum locations, and we'll take a look at that as well. But material setup is a similar thing to job setup. Now, your toolpath operations are primarily those that are in the top half right up here. And then you get your toolpath section here at the bottom, where your listed toolpaths appear. And as I mentioned, down in the lower part here, where some of your edit tools are, we'll take a look at some of those as well. But this first one is just a quick link to your database where all your tools are listed. You've got an edit one, a duplicate, delete, and calculate, and some others along here. So those are just handy shortcuts for all of those. But these are all the primary tool paths that come with it. And as I've mentioned before, you can think of these sort of like different tools in your shop. You have your profile one is much like a bandsaw or a table saw. You've got chisels or drills for drilling, and some other settings here as well, such as molding and that. But tonight and next week, we're going to primarily look at these that I have highlighted here. These are some of the most common ones that you'll use when you start out doing simple designs and simple signs and stuff. And the 3D ones are very specific to 3D carving, which we'll get into next week. But to start out with, the profile toolpath, as I mentioned, it is much like cutting along a line, like a table saw or a bandsaw. And you can use any number of bits for doing that. The V bit will just cut a groove, as will the ball nose or a profile bit or a form bit, as it sometimes is called, could be used along the edge of a work. But a straight bit is pretty common. It can either cut a rabbet, as you can see here, or a dado, or it can cut all the way through for doing a cutout. So those are a couple applications for using the profile setup. The pocket, again, does exactly what it says. It's going to cut a pocket, and maybe a couple of the most common bits for that would be, again, a straight bit for just cutting out an open pocket, or if you have something like a bowl cutting bit with a radius end mill like that, you can actually leave a little date or a little curve along the inside edge, a little fillet. The pocket can also be set up in 2 stages. You can cut different depths, as you can see in the front image right here. The drilling toolpath is somewhat unique in the sense that it really is in there for people with industrial machines that have a drill attached to their machine. Drilling is best done with a low RPM drilling attachment. However, you can do it with a router bit, and we'll talk a little bit about the settings along the way. You just want to make sure that it's very easy to overheat your router bit with the drilling function because it plunges it straight in like a drill press. Now, if you have a collet like this, say it's an 1/8 inch collet or a 3/16 inch collet, you can actually use drill bits with this as well. The one drawback in using either a router or a spindle to drill holes is that they're a high-speed tool. Most drill presses, as you know, operate in the hundreds of RPMs, whereas a spindle operates in the thousands, if not tens of thousands of RPMs. So that's one of the issues with using it as a drill. But it will work, but I'm also going to show you a couple techniques for routing holes using the profile toolpath rather than the drill bit. We've talked quite a bit about the V carving. And again, these are the 3 basic V carving techniques: full, stop depth, and around the outside for a reverse V carve. We haven't said much about texturing yet, but the texturing toolpath is a semi-random pattern that's created by the computer using some sort of ball nose bit typically, or a V bit to give you this kind of hand-carved, simulated hand-carved texture. And it's quite nice, and it comes in really nice for doing signs or other types of creative work. The 3 main windows, when you open up, you get your primary toolpath from this window. That takes you to your edit window, which you have a lot of settings. We're going to talk about the settings as well in detail. But then the main one that this opens up to is what's called your tool database. Your tool database is a library of tools, and you'll get a default set of tools with VCarve when you set it up. But most people find over time that they simply end up overriding it with their own settings because you're able to customize this to match the exact bits that you have in your shop and match them with the kind of material that you're cutting. So it's very customizable, and I always advise people to do that. Teachers I work with, they'll often strip this back just to the 6 or 8 bits that they're going to have on the shelf for their students to use. They have pre-programmed in all the settings, and they just have their students start that way when they start out. So we'll take a close look at setting up the tool database as well as we go along. So in this example, I want to cut out this toolbox. I'm going to grab the profile toolpath. And the first setting at the top here is I've got a depth of cut set at 0.75. Then I'm going to select my tool bit. When I open that up, as I mentioned earlier, that opens up the tool database. You then can select from the left side over here which type of tool you want. Now, VCarve and Vectric have added to the capabilities of this tool database considerable amount of flexibility and options over the last couple of versions. And it has added a lot of options, but it also has made it a little bit complex, because it used to be that you didn't have the option. If you look at the upper right here, you can choose your machine or set up your own machine. You can choose what kind of material you want to associate with. There's a lot of virtue to these, and I'm going to demonstrate some of these next week when we get into the live session with VCarve itself. But if you're feeling a little overwhelmed, if you're brand new, the good news is that when you first start out, you can almost ignore both of these, although I know with version 11 now, they have you picking a machine in a post-processor. It gets a little complicated. So maybe if any of you have had trouble or are having trouble setting this up, before class next week, I may actually just do a little Q&A if you've got questions about your database or your tool setup, and I can clear up some of those questions. But we won't have time to look at that tonight. Anyway, you select your bit over here, and from this list here, as I mentioned, it can be customized. And once you select that, this area then at the right side represents all the settings for that bit. So if we take a look down this list, the first one, of course, is the type of bit. We've got a list of end mills listed here. If you were to click on that end mill, you could actually see the different types of bits that Vectric has available for you to default to. So you can have categories for all these major bits, and each of these bits types, like this end mill, has a certain kind of setting down here. When you go on VBit, the settings down here change a little bit, the kinds of parameters you need to set up. And it's true of all of these. But one of the handy things in this is you automatically see the number of flutes, pass depth, and you see a little simulation of the tool at the right side. Now, any of these different types of bits, as I mentioned, here's some of the examples that are in that list. And we talked before class, we were talking about some tapered ball nose. This is what a tapered ball nose looks like. And Freud does, in fact, make some very small tipped ball noses that allow you to get some really great detail when you're doing 3D carving. As I mentioned too, though, if you're doing V carving, a very fine pointed engraving bit. Now this one actually has a little bit of a flat on the end, and some of them do, but you can get some that are very pointed at the end. And most of the ones that I use, I think, have about a 5/1000th flat on the end, which is common, or even a 0, but they give very great detail for doing very tiny V carving. Of course, ball nose will come in different diameters. Your standard V bit with a 2 flute in this case, used in a similar way as the engraving bit. Engraving bits technically have that flat on the end because they're used for engraving on brass or metal, and that's what that little flat tip is used for. But they also work quite well in wood. As I mentioned earlier, the one like an OG or a bead profile such as this, or a cove profile, is called a form tool, and those need to be set up, custom set up within VCarve. A couple of the parameters that you need to be concerned about when setting up a bit is, one is the diameter, and the diameter in VCarve refers to the cutting tip. So even though the thickness here is taller or wider at the top, it is the diameter here that you're concerned about in the case of a ball nose or an end mill in this case. So the diameter refers to this dimension right here. And again, we'll look at some of those settings, but that's the basic diameter reference. The number of flutes is exactly that. 2 flutes at the top, single flutes at the bottom. These are the 2 most common that you're going to be using in woodworking. Now, metalworking has 3, 4, or more flutes perhaps. But I really advise people, for reasons that we'll look at later, for called chip load, you're far better off using a 2 flute or even a single flute because you'll get a better chip load. They're more common. They're not maybe necessarily less expensive. In fact, you can get some pretty inexpensive metalworking 2-flute spiral bits that will actually do a good job as well. But products such as Amana or Freud, you're typically going to see a 2 or a single flute bit, and either in a straight flute situation or a spiral situation. And again, that's where that information is entered in that list right there. Now, pass depth, we looked at that a little bit earlier. Pass depth is how far the bit's going to cut each time it goes around doing a pass. So in this case, I'm cutting through 3/4 inch material in 1/8 inch passes. So it's going to take 6 passes around to cut all the way to that final depth of 3/4 of an inch. And that's where that pass depth is set up. Step over, mentioned that once before. Step over is a little bit like mowing your lawn. You know, in this case, we've got a 40% step over. So 40% of the bit moves over every time you take a new pass. And so 40% is pretty standard for doing pocket cutting, but you can adjust that anywhere from, 7% to 99%. But 40% is pretty common for most standard work. If you have a spoil board in your table and you're surfacing your spoil board, in that case, somewhere in the 80-85% probably makes sense. One of the reasons for 40% is that it always keeps the tool on the leading edge of the cut. So if the tool, which is rotating clockwise, it always keeps that half of the bit engaged in the material. Now, if you're doing a full dado like we have at the start cut, of course, both sides are engaged. But that's just kind of a rule of thumb, and I find it usually works well. The settings down below here are feed and speeds. You'll hear that term quite a bit in the CNC world. And feeds refer to how fast the machine is moving forward, and speeds refer to the spindle speed or the RPM. For example, if we look at spindle speed, that's the rotation or the RPMs of the router bit itself. And somewhere, if you have a spindle on your machine, you're probably going to operate somewhere between 12 and 24,000 RPMs. I tend to operate a little bit more in the middle of that range. Some of it depends on the size of the tool you have. If you have one of the smaller tools, such as an SD series or the HD4 or the Piranha series, and you're using one of the high-speed routers, such as the Bosch router or the DeWalt router, you're going to be up easily twice this, because a lot of their low-end speeds, especially on the Colt and the trim routers, don't go very low. And we'll take a look at that later as well. But this represents the speed of it. Now, it's important to know also that if you're using a woodworking router in your, if you have a Shark or a Piranha, this speed information does not transfer to your machine. You still have to manually set the speed at your machine. It's only the new machines, probably since July of this summer, maybe last spring, some of you, if you bought an HD5 series tool, 500 series tool with a spindle, or you recently bought a spindle, they do have speed control that's automatic. But historically, and for all woodworking routers, you have to set the speed manually at your machine. But we're going to take a look at how this is still important within VCarve, because you need to use this number to calculate what's called chip load over here. But before we move on to that, your feed unit, you want to make sure that's set inches per minute. That's typical for a Shark tool, and most other industrial tools also use inches per minute, but some do use inches per second. And so just be aware of if there's a default for your tool, what you need to set that up at. Feed rate is the forward movement. You can think of it like miles per hour. It's the forward movement of that tool. And of course, plunge rate is the vertical movement. So it's how fast it's plunging it down into the wood. And there's some rules of thumb and some standards that we'll talk about that work well for small desktop machines. Now, chip load is this term that you're going to hear a lot about. And chip load, simply put, is the thickness of the chip that's coming off of the router bit. And it's calculated combining your feed rate, which is right here, your RPMs, which is your spindle speed, and the number of flutes, whether you have 1 or 2 flutes. Well, the neat thing about the new versions of VCarve is they have the chip load calculator built in. So it'll automatically show you what that calculated number is right here. But before I show you how that's done, I wanted to show you that the reason that chip load is important is that the chip helps to take the heat away from the router bit. And you'll usually get a better edge quality. You reduce chances of burning the edge of the wood. If you've ever taken a handheld router and gone slowly across some material, you'll notice how you can burn the wood. Well, burning the wood in CNC, it's possible. But the bigger challenge for CNC is that if you overheat your router bit, you can actually degrade the sharpness of the edge. And especially in commercial situations, that's what they're really concerned about. They, of course, they want efficiency. They want to get the job done as quickly as possible. We all want that. But they also want a good cut quality. So they can't go too fast or they'll get a rough edge. But if you go too slow, you also will overheat your bit and potentially wear it out prematurely. Now, it's a little harder to control in small machines. So I'm going to be giving you some, if we come up here, we're going to look at some numbers that are kind of, again, the kind of rule of thumb numbers. From my experience working with all different size machines, I find these work pretty well for the small desktop machines. There are exceptions, but generally, I'll give you some numbers to target. So this next slide has a lot of information on it, and we will walk through this little step by step here. So as I mentioned earlier, right at the top here is the number of flutes. Now, 1 and 2 are the most common in woodworking, and a single flute actually makes it easier to achieve what's called a larger chip load. And I'll show you a couple of examples of that in a minute. But this is really valuable if you're using a small router, such as a Bosch trim router or a DeWalt trim router in the Piranhas, especially for your straight bits. I often will use a straight spiral cut single flute for doing a lot of cutting. I also recently switched over from a 2-flute V-carving bit to a single flute from a Mana. It's an insert. I may have mentioned it earlier, but it's really become a favorite bit of mine. And I can include some information on that in the email as well. So you have some links to some of that. Anyway, so single flute really helps you to achieve, especially when you have these high RPM routers like the trim router. On the spindles, I usually find myself operating somewhere in the range of 14 to 22,000 RPMs if I have an actual spindle on my machine, which I do. If you have a router, such as, again, the trim router or the Bosch 2¼ horse, somewhere between 60 and 90% of power, which is probably going to be like settings 3, 4, or 5 out of 6, will get you in that speed range. And there are some charts out there. You probably have it with your tool. And if you don't, I have a copy of that too. I can get that to you, but you'll see kind of the range that you need to be in. There's no need to run the router typically full RPMs because you're up in the high 20,000s or even higher, and it's louder. It also will prematurely wear the router out. And you just don't generally need that much RPMs out of especially the trim routers or even the woodworking routers. Now on the chip load, this is the target number. It's somewhere between 0.002 and 0.01. It's a pretty broad range, but I find I usually end up someplace in the middle with my HD 510 tool. And with my SD100, I'm a little sometimes on the lower end of that. And some of it has to do with sound and just the results you're getting. I'm going to show you a chart at the end here that actually gives recommended chip loads. The challenge is that with a lot of the small desktop machines, it's really hard to get the recommended chip loads. You end up sacrificing a little bit, going a little bit smaller than they recommend, but I find it still works pretty well. On the feed rate, the HD5 series has a max of 200, and I routinely operate my machine between 150 and 180 with really good results. So if you have an HD5 and I'm doing like pocket cutting or profile cutting or finished 3D carving, I'll crank up the speed, and I don't take a real heavy cut depth, but I'm able to get the job done pretty effectively with that. On the HD4 Prawn or SD series, you're going to be down here closer to 100 or lower. And then for small holes, like if you're routing out small holes or small areas, you may even drop down a little bit further in your speeds. Plunge rate is typically I'm somewhere between 50 to 100% of my feed rate, but I rarely go over 100 inches per minute with my plunge rate. There's just no value in driving your bit down into the wood any quicker than that. Now the pass depth and step over here in the left side here, what's interesting, those have no direct effect on chip load. So you can modify those any way you want, but it's based on how well your machine is performing. So obviously, if you take a real deep pass depth and a real big step over, it's like cutting, with your grass, you're just taking a full width of your lawnmower and you're cutting 6 inches of grass at one time, and your lawnmower or your CNC is likely to bog down. So rather than do that, go conservative on these numbers and work on keeping your feeds and speeds in a good target zone, and go a little lighter on these areas, because that'll put less stress on your machine and less likelihood of your machine skipping out or the motor stalling out. What I have over here in the pass depth, I find that with my HD5, I'm regularly carving around, if I'm doing maple or walnut pocket cutting, I can easily do an 1/8 of an inch pass depth. I've even gone deeper than that. I've done MDF at 1/4 of an inch. It really hogs it out. So usually I'm at about an 1/8 of an inch, but you can be pretty aggressive with the HD5 tools at 1/4 inch bit. Even on a 1/2 inch bit, I probably would still just limit it to an 1/8 of an inch. On my SD100, I tend to back off to somewhere between a 1/16 of an inch or smaller, as I've got noted here. Part of it's a feel that you'll develop for your machine. And then, as I mentioned, your step over is going to be somewhere around 40% as a default. A lot of information there. Any questions on this? So I can try and help clarify it. I know I kind of just went right through that, but I wanted to get this out in front of you. So any questions on this? Well, I tell you what, I'm going to send this information out to you. So go ahead and, look it over, test it out on your machine if you get a chance this week. Bring your questions back next week and let's compare notes and see how it worked for you. But a lot of people look at all these numbers and they're like, well, where do I start? So what I'm trying to do here is give you a target point to start out. And you'll notice, again, this chip load is that's kind of your bullseye number. You can adjust your spindle speed and your feed rate up and down, as well as your number of flutes. And as you change those, you'll notice that your chip load changes. So if you keep your chip load, typically, let me go to the next slide here. So here I've got, again, tip 1, targeted chip load of 0.002 to 0.01. That's probably your far ends. If you are working with a small tool, you're going to be on the lower end of 0.001, say 0.003. With the larger tools, I find myself right around 0.005 plus or minus, something right in there, even with my HD5. I don't go up to 0.01 too often. It's pretty aggressive. Take a shallower pass depth to maintain feed rate and chip load. That's a good tip. and then as well as using a smaller step over, because that'll also put, like I said, less load in your tool. Okay, so seeing this picture here, this is ideally when you're cutting wood, you should be getting little shavings. If you're really just getting dust, then you are probably running your router too fast on the RPM, or you're moving it too slow, because you're just taking tiny little cuts, and you're definitely going to overheat your wood or your router bit. And you're also just probably wasting time. You can probably get the job done a lot quicker. But you notice I'm not cutting too deep. I'm probably cutting about 1/10 of an inch here with this 1/2 inch bit, but I'm getting these beautiful shavings off of this piece of walnut, and I'm moving along at a pretty good pace. You can see my settings over here in the over left over here. I'm running at 180 inches per minute. Now, experience has shown me that while I had this one set up at 12,000 RPM, I've started running my spindle a little faster than that, and it drops my chip load down a little bit, but I like the results. I'm getting a little smoother cut at the bottom. So somewhere 14, 16,000, I tend to prefer. But as I said, at the end of the day, you're really trying to make some little chips off your wood. This is actually MDF. This is off an industrial machine, so it's not off a desktop machine. Now, closing up this technical discussion, these are actually chip loads from Freud, and I will send you this handout with a whole lot more information from them. Their advice is good, but you're going to notice something as we look through this, especially if we get up to the 1/2 inch bit. Notice these chip loads, 0.02. And you're going to have a hard time with the desktop machines, given the fact that they have a maximum feed rate, the HD5s, of 200 inches a minute, and you're dealing with a lighter duty spindle as well as lighter duty drive motors. You're going to have a hard time achieving chip loads this high. But with the tests that I have run, I have found, again, you can see here, 0.004 to 7, that's right in the range I mentioned to you, or 0.002 to 0.005. I find that those actually work quite well. And you have to make a few compromises with the desktops because they're just a lighter duty machine. And these specs here are really made for industrial machines. But any questions on that from anybody?
I just have a comment.
Yes.
And so I do a lot of end grain cutting boards, and going in the Y direction, going up and down the path is pretty good. But when you try and go in the X direction, you may want to take a shallower cut, because it had a big problem with it. And I don't know exactly what the reason is, but whether it was machine, chip, speed, whatever, I had to really just have to cut to make it all go smooth. Otherwise, it started having a big problem with the spindle on an HD4.
So I was going to guess you had an HD4. The HD4 is actually weaker in the, or there's more flex in the X direction or the Y. When you go in the Y direction, you basically are dragging that router bit along the whole length of the table. But in the Y direction, it's kind of going left and right a little bit. If you have an HD4, that is a lighter duty machine. The HD5, and I had an HD4 prior to my upgrade, and the HD5, it's pretty amazing the difference in the results. So, are you aware that you can get a gantry upgrade for your HD4?
No, I thought you mentioned that briefly, but
I think I sent some information on the last email. I'll double check.
You did.
Andy?
Yes. The link is in the email at the bottom.
Okay. Yeah, so check that out. There's a great, that's what I put on my machine. And I think it's about it's like $1,000 after trade-in.
Depends.
Yeah, okay.
The one that I'm looking at is like 1,540, but I have the extended bed and I chose to do the 80 millimeter spindle.
Right. So the spindle is an add-on to that. But I think the gantry itself, I think you get $500 credit for your existing gantry.
Randy?
Yes.
Yay.
This is John.
Yes, John.
You and I had talked about that last week, and I went online to Next Wave, and they quoted me, I think it was just short of $1,000 for the gantry upgrade and the firmware.
And did they ask for a trade-in?
In the email that they sent back to me, I do not recall.
I'd go with it then. I have heard via a couple of the customers that they may or may not ask you to send back your existing gantry. I can't guarantee that, but I think you're right. I think it's around $1,000, but boy, it's the best $1,000 upgrade that I put into my machine. I'll tell you that. I love this HD5 as far as the format compared to what the HD4 was performing, the rigidity of it. It's really a nice upgrade.
Is that the biggest difference between the HD4 and 5 is the gantry?
It's pretty much the only difference. I mean, the HD5, they actually have some side skirts, which are pieces of metal that kind of hide the undercarriage, but it's not a functional item. It's just a cosmetic item. And I think the logoing on the front is a little different, and maybe the way the cable carrier, I think the full version of the HD5 may have some sort of cable carrier along the side or something. But no, the real important difference is just the gantry itself.
I will look into that. Thank you.
Yeah.
Hey, Randy.
Yes.
I noticed you haven't mentioned anything about the white side bits. I don't know if that's do you not like those, or
I have I have nothing against white side.
Okay.
The only the only bit that I've there are some cheap Chinese bits, there's some cheap American bits even out there. It's like a lot of things. You kind of get what you pay for. But
Right.
Sometimes you just I've used some pretty cheap, like $5 straight bits to hog out some dirty lumber I was machining one time, and it was the right bit rather than using my $30 Onsrud bit. No, Whiteside makes excellent bits. Amana makes some great bits. Freud makes some great bits. The only beef I got with Amana and some other manufacturers is when you get a 2-flute V bit, sometimes the tip of the V bit is not sharp pointed. It's sometimes, I call it a shovel nose. And Freud, I've talked to them about this, and a couple other manufacturers the same way. They don't have a very good point on their bit.
So is there a brand name that you definitely would say, hey, don't even think about buying any, because these are junk?
Well, no, not really. Again, it depends on the use of it. Like I said, I've used some $5 straight bits to hog out some lumber, and they lasted me a couple of runs, and that was good enough for what I had to do. But I have both some pretty inexpensive bits. I have some Onsrud, which are kind of on the high end, and then you've got Amana and Whiteside and Freud, which are kind of along in the middle a little bit more. Part of it has to do with not all companies carry all the same profiles.
Yeah, I've noticed that.
I will say a couple of my favorite bits, partly for price and performance. Freud has a 1.25 inch mortising bit that's, I think, less than $30, and it's both a 1/4 inch or a 1/2 inch shank. And I use that for spoil board surfacing because it's half the price or less of a lot of other spoil board, and it works great. So that Freud mortising bit is really nice for that. I also really like Amana's insert 90-degree V bit, their small one for V carving. It's a super sharp point and it's inexpensive. You can replace the tip. A lot of them make what are called single flute 1/4 inch straight bits, spiral bits. I like the spiral single flute bit for a lot of work. I use that for a lot of work.
Okay.
Oh. There's also this brand, I've been buying it off eBay lately, testing it, and it's called, I don't know if this is right, Yonikan or something. It's a yellow brand. And I've got a few. They're pretty inexpensive, and the product quality has been pretty good. I can send a link out for that as well. You can look for the brand.
They must have gotten better.
Oh,
4 years ago, or 3 to 4 years ago, I've had a hiatus from this, but Yannicka was not very good, and I've broken several, and I'm not a big aggressive pusher on it. So
Interesting. Well, I take all things of that caliber with a big grain of salt. I don't have high expectations when I buy something that cheap, but so far they've performed okay.
do you have a discount coupon, by the way, for the gantry? Because it's listed at 1,500, and if you want the holders for just the holders for the spindle, which I have, is $20 more. So it's 1,520.
Tell you what you do: call their tech support number and ask them what their price on their gantry upgrade is if you were to order it. Like I said, I've been, and I should verify that too. But didn't somebody just say they ordered one and they didn't request the gantry returned?
Yeah, this just says 1,520 is period.
Oh no! If you read down the list, if you drop down that information.
Oh, okay.
There's a
allow
credit.
500 credit receipt if you use.
Yeah. So what you do? They send it to you in a box. You just pack up your old one in that box and you ship it back. It's okay. It's pretty straightforward.
That works. I see it. Yeah. Yeah. Click to read more.
Yeah.
Sounds great.
Yeah.
Thank you for that discount.
There you go. Yeah. The old gantry isn't worth much. So.
Yeah, hey, Randy.
Yes.
How often you lube your gantry on the HD5?
I don't recall what the manual says right now, but I think it's somewhere between 40 hours of time.
Yeah, I think they recommended 30 to 40 hours.
For those of you who have the HD5 and you're looking at greasing it, one of the things that it's a real hassle getting in behind the Z to get the fitting on there. And I've heard that they are coming out with I don't know if it's going to be a retro kit. They're changing the design so you get your grease gun back there a lot easier. The grease fitting is a mini grease fitting, and it's not actually a nipple that holds your grease fitting. It's just all pressure fit. So it's kind of tough to get in there. So to stay tuned for that, I think they're going to come out with a retro for that, either replacing it, new sides you can put on it, or they'll show you how to maybe add a little more clearance so you can get your grease gun back there.
I got an attachment for my grease gun. I got the grease gun at Harbor Freight, one of those little squeeze guns.
Yeah.
Granger has a tip that will go on those grease fittings.
That's good to know because it's not a real common American grease fitting on a lot of machines. I mean, it's very simple, but it's very tiny.
Yeah.
All right. Well, we covered a lot of stuff tonight again, and a lot of it was pretty technical. And I just pushed on through it. Go through the stuff if you have questions. Again, I make the open offer that if you've got a project you're working on, you're hung up on some feature of it, send me your VCarve file. Tell me what issue you're having, and I'll definitely should be able to definitely try to help you out on that. Glad to do that. Or if you have any other sort of related questions to that. And with that, thanks everybody again for showing up tonight. I look forward to next week.
Thank you. Good evening.
Thanks, Randy.
Thank you. Good night.
All right, guys.
Thank
Thank you.
Thanks, Randy.
Thank you.
Thank you.
Thanks, Randy.